Hi, we are going to work on exercise 3.21 on page 128, and you may want to get your book out so you can see these this output from running a regression. So in this example, we have, you can read it for yourself, but we have a bakery, and sometimes they make wedding cakes and sometimes they make gift baskets, and there's a few different variables in here. And what we're trying to figure out is overhead. So overhead is believed to vary by labor, how many cakes they make, and how many gift baskets they make. So we have several different variables here that go into our cost object, which is overhead. So the point is we want to figure out a model for overhead. We want to draw a line with an intercept and a slope that will be able to tell us for different units of overhead how much different overhead costs we'll have. So this is slightly different from the last problem from 3.19 because as you'll see, we have different drivers. That all had the same driver, number of moves. We just had different resources doing the moves. In this case, these are actually completely separate drivers and separate variables. So moves was X, right? When we did that last one, 3.19, moves was X. But these are going to be three completely different X's. So we're going to do multiple regression and figure out a model for overhead. So that's what we're doing. All right, so we've entered all the data into a spreadsheet or something, and we've come up with this output here. All right, so this is the output. I would expect you to be able to read something like this that explains and figure out what the model is. All right, so the first question here, write out the cost equation for Sweet Dreams monthly overhead. So a cost equation, the model for overhead, would have an intercept, right, where our fixed costs are, and then three different variables times three different x's, because these are completely separate variables. You can't add them up. All right, that's what multiple regression means. You're having multiple variables that you can't just sum like we did on 3.19. All right, so the formula is still y for our total overhead cost. So our total cost, y, is equal to an intercept, right? So in this case, our fixed costs are 1980, right? 1980, right? And then we've got our three different slopes. So direct labor hour is x1, so we'll say plus 2.56 times x1 plus 67.40 times x2 plus, I'll just come down here, 2.20 times x3, right? So x1, x2, x3, and these are the estimates for the slope. This is the intercept, these are the slopes for these. And it did that using a whole bunch of different data points that you entered in the system, and it came out with this output. All right, so that is the slope. All right, I'm going to go ahead and stop this video and come back and talk about some of these other things. Now that we've looked at this, I'm going to go ahead and we're going to come back and work 2, 3, and 4 on the next video.